Hello, everyone, and welcome to the latest in InSync's Ask the Expert series. Today, we are joined by Gerard Phillips from Arista, who is a subject matter expert in media and entertainment. Welcome, Gerard.
Hi, Paola. Very pleased to be here.
Great, thank you. Well, if you don't mind, we're just going to launch straight in with the questions. We've got quite a lot to cover, and I think this is some pretty important material. So I'd really just like to start by asking you about hybrid SDI and IP environments, which are becoming much more commonly used now. I think people are understanding more now about the media data flow, but can you tell us a little bit about how a user manages Genlock in a mixed IP and SDI environment?
Yeah, sure. So, traditionally in an SDI environment, we'd have bisyncs or trisyncs. We'd have our black and burst signal, and that would be the mechanism by which devices could synchronize frames and lines such that the TV studio was all lined up. And of course, for 50 hertz worlds and 5994 worlds, there'd be different signals, and so often lines in or lines out, or as part of a sports transmission, you'd have stands converters where you'd need both of those references. In the IP world, it's all asynchronous. And so getting accurate time is quite a different task. That accurate time has to arrive over an asynchronous Ethernet connection. So there's a protocol that's been out there for quite a long time now called PTP, Precision Time Protocol. It's defined by the IEEE 1588 version 2, and it defines a mechanism by which you can gain accurate lock to a very accurate clock at an endpoint using only asynchronous Ethernet. So that gives you the ability for a good network, which is PTP aware and good endpoints have been well designed. You can have a time lock, which is the spec 2059-2 will say that spec should be to plus or minus. Well, actually, they're taking this out now, but roughly plus or minus 500 nanoseconds. So you're looking to have endpoints that are locked to can be a global reference, the GPS network, for example, global reference to plus or minus 500 nanoseconds. So you can kind of see that your SDI devices can be locked to black and burst if that's what you want. If you need that level of accuracy for SDI generation, for example, or God forbid, composite generation, color lock. And then in the IP world, you can have a similar. It's not the same level of accuracy. You don't need the same level of accuracy, but it's a high level of accuracy, plus or minus 500 nanoseconds. The neat thing is that what you want is a single source of that time. So many architectures now will have a pair of PTP grandmasters for resilience. They will create PTP time, and then from that PTP time, specifically designed master sync devices will take PTP and create from that the station's black and burst. So now what you've got is PTP, which is very accurate, with a black and burst, which is synchronized and both phase and frequency synchronized to that PTP.
Okay, so if a company such as InSync were to produce a product that supports both SDI and IP, can the customer then lock their SDI output to the PTP clock?
Yes, you can create SDI from PTP if that's what you want to do. If you wanted really accurate SDI for the purposes of kind of clean cutting, RP168 I think it is, I would maybe suggest that you run black and burst to those devices. But in general, yes, you could run an entire TV station now off PTP. And obviously what you're doing there is you're reducing the amount of copper in the system. Tons and tons and tons and tons, miles and miles and miles of BNC is run to every single endpoint to give it a black and burst. So now it's integral to the data stream as PTP in the media network.
Okay, so in frame rate conversion products, we often find a situation where the user's converting, let's say, 59 hertz to 50 hertz. And in that situation, just going back to the old SDI world, they're using a 59 hertz reference, say with 50 hertz output. So what's the equivalent of that in the IP world, and can PTP handle that type of use case?
Yeah, you have to think of PTP in a different way to Black and Burst. Black and Burst gives you a really good frequency lock and a really good phase lock, but that phase is a very instantaneous lock. It doesn't contain any time data unless you choose to encode time code into Black and Burst, for example. PTP is subtly different. PTP is the messages in PTP are describing the number of nanoseconds since the epoch. The epoch is the point where the nanosecond number was 0, and that is January the 1st, 1970 at midnight. So the number that you end up with in your endpoint is just a number of nanoseconds from this epoch. So it's, I don't know what that number is, millions and billions, whatever it is. And the size of that number is capable to go through till we're all well gone. So what it gives you is not only a way of locking frequency and phase, but also time. So because it does that, what you can think of doing is building you now have a known timestamp in PTP space for every single frame that has ever been made or will be made or could be made or has been made. So if you imagine both those two streams, the 50 hertz and the 59.9 hertz stream, you can project back to there being a frame that starts with a timestamp camera capture point at timestamp 0, PTP time 0, 1st of January 1970, 12 o'clock. And if you work your way forwards from there, then you as a stands converter, you as a stands converter can know at what point you are supposed to project to make a new frame. And any time you like, what PTP time is now, and you can know that you're going to make a new frame, and that frame should have a timestamp of a particular number, a particular time, based off 2059-1 it is. So yeah, you can operate in exactly the same way as you would have done with SDI references. I mean, you'll still use the data coming in as your source time references. They will have RTP timestamps, which are embedded in them, which are derived from PTP time. They don't carry the full resolution, but they're accurate to 12 hours. So if you've got a wall clock time, you can determine exactly when they were captured. And you can then use your internal PTP timestamps, which you're creating based off the PTP you're receiving, running your clocks to tell you exactly when to make a new frame. So exactly the same methods as you would have done with Black and Burst, except there's a standardized grid on which every output should exist.
Okay, that's really good news, I think, and very encouraging. If anybody listening wants to read up a little bit more on PTP, where would you recommend they have a look?
If you're interested in the network side of things, we have a white paper on the Arista website. There's a webinar series that we did with Tektronix and with Imagine, and there's a 3-part series where you can get taken through how does it work, how do you make it work in a network, and how do you manage it and monitor it. So I would maybe start there, and then once you kind of worked out what the lie of the land is and what else you want to know, then you can always reach out to me. I can point you to other stuff as well.
So what I'll do is I'll add those references to the transcript. And so if anybody wants to follow up, they'll know where to look for the information. So I think that is fantastic. And I'm going to say thank you very much, Gerard. That was really interesting. Thank you for joining us. And, we look forward to hearing more from you in the future.
Okay, well, thank you very much for having me. It was an absolute pleasure. Thank you very much.